I think.
I don't believe this.
Yes.
It looks like true.
Yes, I have to show that I do understand recording. Yeah, okay.
Well,
In a-
this doesn't disappear
in
somehow.
a double
Or can you-
in a double screen, it is pretty complicated. I don't know.
Sorry for that. I think you don't have to actually do it.
Well,
Okay,
presentation,
so the story is the following: that Junichi works on theoretical dynamic methodology, and with many special topics in this methodology, and he's a kind of theoretical physicist and does some excursions towards philosophy and whatever. And today's talk will be about a special way of special problems we might have looking at complex phenomena. Am I right, more or less?
yeah, yeah. Well, dziękuję bardzo, Simon.
Okay, so this is your stuff, and we start with the presentation.
Okay. Ale dobrze wieciu, mówi mi was dzieć. And first thing I should say in English is, please stop me. This is a little bit awkward online, but our chair, Simon, will take care of it, and I prefer to be inductive. So that's amazing. Now, this is the title, and slight modification. I changed the Gestalt into Gestalten because it's a German word in science, and I mispronounced subtitle is reflection on ontology, epistemology, and taxonomy. In short, idea is starting from concept of Gestalt, try to reflect on philosophy of science in very specific manner. So that's the idea of my talk. And of course, the main topic of my talk is Gestalt. So what is Gestalt? And best is to see an example. Here is the example of Gestalt. The question is, what do you see on the screen?
I see a duck.
Comment?
I see a duck.
I see a rabbit.
Duck.
I see a rabbit.
Well, I have one audience here, says this is rabbit, and there's someone from online say this is duck. Who is right? Can we vote? Anyway, that's the point of this image, that depends on how you look at it, and depends on your, well, some people see this as duck first and you never see something else, and some people just see it as rabbit and never see anything else. And Simon got special eye and see both duck and rabbit simultaneously, more or less. But that's basic idea of Gestalt. And I said it's a German word, so try to understand this word. This is feminine die Gestalt, and this is from Duden dictionary. First thing to look at is, of course, etymology. That is where this word comes from. And this actually past participle of verb called stellen. And the stellen means to place or to present. So etymologically, Gestalt means something that is placed or something that is present. So that's very basic notion of this word behind. And if you look at dictionary like Duden, you see well, I can't remember, about 7 meanings. Just see first few, well, first couple. The first meaning is this Aussererscheinung is mentioned in Hinblick auf die Alters. Bushes, well, mutual author impression of man in quick look in the matter of this special word, bushes, well, quick drawing of portrait. Well, this is a kind of way to paraphrase etymological meaning. Second is more amusing. Unbekannte, nicht näher zu identifizierende Person. Unknown person not near enough to be identified. So it's really Gestalt. You see someone, you see a person as Gestalt, but you don't know who it is. That's really notion of something in place and present, but nothing more. And so on and so on. So standard translation in English, form or figure. Now, then some of you may say, oh, so German doesn't have a word for form and figure, and they always call die Gestalt, die Gestalt. But that's not true because there are words for form and figure in German, the form and the figure. So the main summary is correspond to English form and figure. There are three words in German, the form, the figure, and the Gestalt. And Gestalt got this special connotation due to this etymology. But we have to remember, and Gestalt sounds very exotic in English, obviously, and probably some extent in Polish as well. So, and it's word hard to translate with this special connotation behind with etymology. So we often use this word Gestalt to point out something is in place or present. But we should remember this is very normal German word. So in short, there are two words in English, form and figure, and correspondingly, there are three words in German, form, figure, and Gestalt. So we should not mystify this word. But anyway, this Gestalt is very handy word to use, even in English. So that's where we stick to. And this is another example of Gestalt. And in this case, question is, can you find number 4 in this structure? Well, probably you can do it in quick if you're good at it. But answer is, yes, I just said here. Well, I guess first question is reaction to this second example. And personally, I didn't like it in first impression because it's kind of trick to find 4. And it's kind of psychological test to see your visual ability and so on. And this actually Gestalt issue is often reduced to the problem of psychology. Because, well, this is a question. You see an image or pattern like this, and the question is, well, it's easy to talk about myself. Me as a subject looking at this object, and I think a way to put this, what I see in my mind based on this object there. So it's problem of my mind or mind of each of you seeing this, that whether you can identify this 4 and so on. So this subject is typically called Gestalt psychology. And if you check the word Gestalt on web, I think first word you find is Gestalt psychology in a bunch of things. But the important thing to emphasize is we should not reduce the question of this Gestalt to the problem of psychology or about our mind setting. This is something objective. Well, this fall is actually objectively hidden. And I think this is a good analogy that how we in science detect the phenomena. And well, just pick this example. This almost 10 years ago, we find that what called Higgs particle. And I'm not particle physicist at all, so I can't explain this image, but this is an image that distributed widely in media. And so this is detection, this is evidence of Higgs particle. That's media's set. And just compare this image to the last one. Oh, sorry, I went other way around. So detecting number 4 in this image is far easier than to see Higgs particle in this image. Of course, this is a little bit of metaphor because the particle physicists did not use this image literally to point Higgs particle, but this is kind of visualization of data sets they use. And using this data set as shown visual way, they said we now detected Higgs particle. So it's like elemental particles or I'm going to refer to Ludwig Wittgenstein in this talk, because this is the main source of inspiration to talk about Gestalt and exclusively on his last work, actually published Posthuman Philosophische Untersuchung. Well, I guess better to talk about this. Untersuchung. This book is title is translated in English, philosophical investigations. But this word Untersuchung gives different connotation. Suchung means seek, and Untersuchung, so something literally means seek under. So he really seeks the solution to philosophical problem in this last slide. And problem is collection of fragments. And so he make one statement, and what follows is not often directly connected to what he writes, but that's what Ludwig Wittgenstein left to us at the end of his slide. Anyway, so this is one remark from this book, Philosophische Untersuchung, and it says, Beobachten erzeugt nicht das Beobachtet. Now, this is another German lesson, I'm afraid, but beobachten is principally verb to observe, and this beobachten here is used as a noun, observation, and this das beobachtet. Beobachtet is again past participle of beobachten. So this is something observed. Now, two nouns are connected by verb erzeugt, infinitive of erzeugen. Well, zeugen is some to point or pull, and er is kind of typical prefix to verb in German. It's like a pull out or point to something. So observation erzeugt nicht is nie in Polish. observation does not point to what is observed, or observation does not pull out what is observed. Anyway, the point this is exactly from this image. This is Bell-Baxter. And Bell-Baxter here is Higgs particle. And we always see complex relationship of Bell-Baxter, and that's Bell-Baxter. And that's kind of important context of this Gestalt issue. So question I pose is how to figure out this question of Bell-Baxter, and more specifically, the question of detecting something out of Bell-Baxter, well, particle phenomena and so on. So before proceed, I think it's a good idea to put some philosophical background. And we should consider three subjects in philosophy in this context: ontology, epistemology, and taxonomy. And I give slightly non-orthodox meaning to ontology and epistemology. Ontology for me is question of what is knowledge, or what constitutes knowledge. So we make a remark or statement, and is it really objective knowledge or just expressing your emotion or feeling? That's most fundamental question of ontology. Now, once we solve this question ontology, epistemology follows. So we know what knowledge is once we solve problem ontology. Next is how you know or how to get this knowledge, or how to construct knowledge that once we know what knowledge is. So that question epistemology. And taxonomy is a little bit particular, but we need this because, well, knowledge kind of collection statements, but you can't just list knowledge number 1, number 2, 3, and so on, then you get minimum of knowledge. The next step important is put them together and put into structure. So that's the question taxonomy. It's a little bit special way to put this issue, but my major quotation is Michel Foucault's book by Le Mot et les Choses, and he claimed he used this terminology to refer to problem of structural knowledge as taxonomy. So this is an important background, and as my presentation goes, you would see the issue of ontology, epistemology, and taxonomy. And so for this reason, the three concepts you have to keep in mind. And only thing I don't do is, now this is problem ontology, this is problem epistemology, and so on. It's kind of tedious. And my hope is you as audience pick up, oh, now this must be ontology, this must be epistemology. That's I expect. Anyway, so this is the background. And now I move to very specific knowledge to discuss about detection issue of phenomena in science. And because I'm atmospheric scientist, take atmospheric example. And the example I take is what we call convective organization. And okay, to see what it is, you have to see a picture. Now, I'm not sure how many of you are familiar with this kind of picture. This is the whole globe of Earth from particular direction. And this is, well, you see underneath Australia and Philippines, and you see left top the China and Indochina and so on. And this image itself is kind of first color, the emission intensity of infrared from the Earth. So this white, this reddish part is actually lowest in emission. and bluish part is emission from ocean or surface. It got higher emission value. And I realized I have to explain a little basic of physics, but this emission is measure of temperature of the emission level. So this got higher temperature, and this green got medium level, red, and then white is lowest temperature. So these are coming from very high levels. And then in short, make a long short, you see a structure of clouds in this infrared image. And in this way, we can see what we call convective organization. Now, I have to say one more thing, because these are clouds, and we call it convective because these clouds are generated by a process called convection. I think that's enough to explain in this context. And this is organized into this global scale. Then the question is, do you really see it? Well, we see this cloud cluster here and there's some structure. But as a whole, we see that this whole cloud distribution cluster into single structure, loosely speaking. So that's what organization means. And point to emphasize is this cloud distribution, complete cloud distribution is not organized in this manner always. And being said this, I want to show another slide to show the same thing. And problem is I can't find this slide which I collected more than 20 years ago because website doesn't exist anymore. So the structure, this is different format, but just see this state gives much less organized structure. We don't see well-defined clustering. So sometimes we see this well-defined cluster and sometimes not. So that's one question. The next question is how the structure, this organized structure evolved with time. So one way to see it is plot this in, function of longitude, horizontal direction, and time in vertical direction. And time goes up vertically. So this is a distribution of infrared emission along the equator, more precisely 50° north to 50° south. And this is what you see. This is a Pacific Ocean, this is 180°. This is states, and Indian Ocean somewhere around here. And this is, no one sees this, right? IDIs.
Everyone sees it.
Yeah, Atlantic Ocean. And you must keep your eyes sharp, but we see this cloud structure, compact cloud structure moving eastward with time. So this is the first one. And second one goes like this. And convince yourself, I replot the zoom up one event over January to February here, and we see this structure moving eastward with time. So we see this organized convection typically in planetary scale, typically move from west to east. And this is just, infrared field measuring cloud heights, as I tried to explain. And same structure identified with different physical variable. Now, this idea, this interdisciplinary talks, I should explain what vorticity and divergence are, but never mind. These are characteristic how winds evolve in different sense. And for vorticity, this is left-hand side, I pick up 800 hectopascal across the surface. And divergence, I pick up 150 hectopascal. That's kind of top of troposphere called tropopause. And beg your pardon, this is not same period, but time goes upward vertically, and horizontal axis is longitude, again along equator. I hope you see similar future that going eastward with time. So point is, it's not only cloud structure moving eastward with time, but various physical variable also move eastward with time, associated with clouds and convection. And this structure is called Madden-Julian because this structure is originally identified by Madden and Julian in 1972. And this is a schematic that is typically, as we see, it's typically generated over Indian Ocean and move east. So this schematic go downward in time. F is top is earlier stage, and E at the bottom is later stage. When we see schematically drawn clouds moving east with time, up to date line in Pacific Ocean, as seen in Flame Sea. And well, clouds disappear, but winds profile keep moving eastward and make a cycle taking about 30 to 60 days. So these are the actual cases of this Madden-Julian oscillation. Now, so question is, how can we identify this Madden-Julian oscillation, or MJO? There's about hundreds, well, many dozens of work to identify this structure in objective manner, instead of looking at I and say, here we got Madden-Julian. And these are two examples how it is done. Now I have to apologize, I'm going this time downwards vertically, but horizontal axis is longitude as before. And left, okay, the top frame, top pair and bottom pair. Top pair shows this infrared field as well. So this shades are same thing. You may not feel same way, but you just have to sharpen your eyes, and shades are same infrared field, and we put different contours that indicate in two different methods for identify MJO. This is method based on infrared field. So of course it overlays very well with infrared field itself. And this right side is based on velocity field. So we don't see good matching of infrared field and this detection shown by contours, but well, both methods kind of identify same Madden-Julian phenomena, but noticeably different ones. The lower pair makes same point in other way around. In this case, contours are identification based on infrared measurement. But now we plot left side infrared field, and this is the wind speed in eastward direction at across the surface, lower troposphere. And now this makes opposite point that how this detection based on infrared field match well with eastward wind field. Of course, two things evolve together. Well, this way, I'm sorry, from upper right, upper left. And so question is, how we do this better or best? And to ask this question, we have to get back to the question of what we really mean by identification. Well, probably it's clear naively, but I'm not sure. If you try to look at this, we just pick up two physical fields and just two different identification methods. And of course, these are not two options for identification, not only two, but about dozens. And physical field, we have to look at this, not only two, but well, we can make endless list. So we really have to ask what we really want to do. That is question of what is identification. And here we get back to Wittgenstein again. And this quotation is rather too long, so I'm still struggling how to quote this. And this unusual part, the two segment, he put number 122 and 123 here, is not usually continuous, but in this case, it's pretty much continuous. So I put two statements together that hints together, in my opinion. Zu sagen ist hier jetzt aus, hätte für mich so wenig Sinn gehabt. Well, if I see something as doesn't make sense to him, aus beim Ausblick von Messer und Gabel zu sagen, ich sehe jetzt das jetzt als Messer und Gabel. So it's to say, see as something as is like just looking at Messer und Gabel's keyword, knife and fork, and then say, I see them now as knife and fork. Do we say that looking at knife and fork at the table and I see them as knife and fork? We just see knife and fork and table. That's it. That he says, man boosted this as also the need first thing, because we don't understand this kind of quasi-logical statement, and it's not better than even the benefit either das ist jetzt mich eine Gabe oder das kann auch eine Gabe sein. Well, we can say same thing in a much easier way. Now, next he says, man hält auch nicht, was man bei Tisch aus Essen Essbestück erkennt für ein Essbesteck. Now here, he changed word Messer und Gabel to cutlet in more general sense. And this is really Wittgenstein German and tedious. We do not hold that, well, other thing is this erkennt is a key word. We, by dish, by table, the cutlet is something erkennt for us. And this erkennen is, well, said by this, we see cutlet as something we know. But this know, word know got two words in German, and Polish is better. This kennen is znać, and another verb is wissen, that become widzieć. So erkennen is something we know by heart. So we see cutlet, knife and fork on table. We know what these are by heart. And we don't help them hold this what it is really. And it's like, so wenig wie man beim Essen, when we eat, für gewöhnlich den Mund zu bewegen versucht oder bewegen muss. Gewöhnlich by habit we move mouse, Bewegungen, without thinking. And same wise, we pick up knife and forks because we know already what these are. Das irrelevant. Wir kennen schon. And so anyway, so this is by translation. When we imagine we went to a very exotic restaurant and got something straight on the table, normally when we get knife and fork. But we have to figure out, you must be intelligent with this very fancy restaurant, and they put something fancy. So you have to figure out which is knife and fork. What you would do? Shall we look at this strange pair with your eyes and look at geometrical structure like this time and longitude section and try to detect structure Mendelian? So we just pick them up and try to use them. And by moving them, we will figure out which is knife and which is fork. So that means identification is not to pick up right geometry in data or image, but rather than how it functions. So knife got special shape and fork got special shape. And you might train by artificial intelligence, but main point is we know how to use it. And that's what makes knife and fork. And so identification issue is not geometry, but how given phenomena or process is working. It means, as almost said, for identification of phenomena, we must first know the mechanism of given phenomena. And we shouldn't reduce to just whatever identification of structure, pattern, and so on. Just as said. Now, I guess this is enough for philosophy for now. Anyway, so just forget all I said so far. And whatever I said so far, we just want to quantify what they've organized. And there are a lot of methods around, so why not just pick one of them and try it? So example here, I take information entropy. Again, my apology not explain what it is in very well, but this kind of famous, well-known quantity, and normally this quantity called information entropy is designed to measure degree of organization of a given system. So just use it and try to quantify degree of organization or convection in the atmosphere. So that's just, we did it and plotted the time series. So it's about over 15 years, I can't count, about 15 years of time series. And so vertical axis is value of information entropy about area of, well, bit of Indian Ocean to Western Pacific. And well, red curve is original every 6 hours, I believe, time series, and green is monthly average. So you see something, okay? With a bunch of variability, and you can take spectrum and so on. You see actually daily cycle peak and annual cycle. And if you know what El Nino is, you see a signal of El Nino, and so on. Now, but that's fine. But you have to look at this plot just as it is. And point is, this information entropy varies only between 0.9 to 0.91. And most of the time, it stays around 0.9. And I forgot the main things that information entropy is normalized to give value 0 to 1, and larger is less organized. So naively speaking, atmospheric convection is always state of 0.9 information entropy. So naively, this is not organized at all. And we see episode of Mendelian and some quiet period and so on. So we should have, if Mendelian oscillation is detected by this time series, we see more bumps up and down, but we don't see. We always see 0.9 regardless of phase of atmosphere or convection. And this is point to make upper frame is state of lowest entropy over whole time series, and bottom frame state of highest entropy over whole period. And of course, you see a domain for analysis Indian Ocean and Pacific Ocean, Australia, and Indochina and Malaysia, so on. And okay, upper frame got more organizational lower frame, but you see more organized states than this in previous slides. So we can quickly conclude that lowest entropy state is not most organized, and least organized state in this area. Called EOF, empirical orthogonal function. Now, again, this is jargon, and in different community is called single vector decomposition, and another name is proper orthogonal decomposition. Anyway, we decompose into modes, and we use this to calculate information entropy. And we just calculate the spectrum of this mode intensity in decreasing order of contribution. An important thing to notice is this distribution follow power law with slope is something like minus 0.55. And again, this is something that if you're in right domain, if you saw this algebraic decay of something, this is something exciting. We see another power law as with embedded turbulence flows and at critical phenomena was self-organized criticality. And the short explanation is because it only goes down algebraically rather than exponentially. So we have some of all those contributions to count information entropy. So that becomes fairly large in the end. So the key point is that this atmospheric convection got the link to what we call critical state. So look at next step to look at is simple ideal simulation of critical phenomena called Ising model. And this very simple model that spin got dichotomy of either +1 or -1. And as at higher temperature limit, because heat disturbs the system, so you get random distribution of +1 and -1. And as temperature decreases, the whole system get to the single spin sign. This white area means 1 + 1. In this particular simulation, it ends up with +1 homogeneous distribution as temperature getting lower. So this evolution of the spin distribution power with decreasing temperature from highest to lowest. And what we see is it doesn't get to this complete random state to complete homogeneous state smoothly, but we see something structured as temperature going downward. If you see two upper frame and move to this left bottom, you see some clustered structure. And this state is called critical point. That without getting to what it is. Anyway, so this is interesting system. Look at how information entropy measure this organized structure we find on the critical point. So this is just exercise. So horizontal axis is temperature increasing. And then we plot two things. In orange, the mean spin value, it gets to 1 in average in low temperature limit. And high temperature limit, you get random plus and minus everywhere. So you get mean value. And critical point is here. That's this almost zero value suddenly jumps to finite value. And we see here very organized structure. But if you compute entropy, it just flips sign of this mean value of spin in this system. So in low temperature limit, when it's homogeneous, it's zero information. So information point of view, information entropy point of view, this homogeneous state is most organized. And at a certain point, this information suddenly goes up. And this critical point got as much disorganized as high temperature limit. Again, we failed to identify organization by information entropy. So jump to a conclusion from this, that science is a matter of application recipes. Well, this information entropy is very handy recipe to take. And if our popular belief is true, we can quantify any type of organization. And it doesn't work. So we have to, so here is a question of taxonomy that we have to think carefully our structural knowledge to address what we want to address. My talk kind of detour from question or Gestalt, but I believe I stayed close enough. So I didn't say much about Gestalt in last half, but we should get back to this Gestalt. And so main question is how to detect phenomena or structure and quantify and so on. And think all those things and get back to the concept Gestalt. We might say this question Gestalt is how we can see as it is. See as it is. An interesting analogy to take is question of visual art. And in popular history of visual art, we learned that Renaissance is brewing period, that we suddenly realized that how we can draw as it is. And this persuasion of drawing what we see as it is continue whole art history, so to say, until Pablo Picasso destroyed it. So that's the way we see the historically, classically, the goal of visual art is so people see as it is. And it's a good book to read by Gombrich, Art Illusion, that he points out this is not true, that the notion of see as it is not that obvious as just as said. And that gets back exactly question Gestalt. What we see is not really well, as it is, but it's more like a Gestalt. And we go through, if we go through this history of art in this manner, again, we can get back to science. And I like to conclude my talk with rather long quotation. I hope everyone can read it slowly enough. Well, problem with Gombrich is he writes English in German style, so it's a bit tedious to read. So you might have to slow down, but I believe this text summarizes what I wanted to say in my talk in words of Gombrich, and I found my talk the quotation of Gombrich, and I like to stop here. Thank you about it.
Okay, thank you very much. Yes, and now we have to.
Well, I'm not sure everyone read it already.
Hello, can you hear us? Are there any questions and comments?
Yes, we can hear you.
Hello?
Yes, we can hear.
It doesn't work.
You've heard this, you know.
Yeah, we don't know.
Yeah. Okay.
No, I don't.
Hello, Piotrze.
Yes, we can hear you. This is what I wanted to say.
So what is your hypothesis? What was the question?
Oh, I prefer to hear hypothesis.
Yeah.
Anyway.
So my suggestion is the following. You are telling us that still it's very difficult to be objective in a sense.
Yeah, you can say that. That's another way to put into conclusion.
So even if we make a kind of very advanced technology and very advanced mathematics, or to derive something from representation, unless you don't know the mechanism, it's difficult to say what it is, yes?
Well, mechanism is kind of middle point of whole discussion. It's not key that we tend to think identification is see a pattern as a geometry. But so we have to think about function, well, mechanism. But I think getting to question objectivity, I think best answer is get back to first quotation of Wittgenstein, beobachten erzeugt nicht das Beobachtet. So, whatever methodology you take, that is your choice. So nothing is perfect objective in absolute space. I think that I want to say. Hold on, is it good news? I don't say anything to this side.
Yes, it is a good news since we now one screen only, and we see everyone.
No. Shall I talk a bit about objectivity? Well, I guess I hope more questions come. I can say more about this, but
okay. No, are there any comments from the audience?
oh my God, did I give a perfect talk? Is it either perfect or awful? I think.
No, since everyone was excited with your paper in BAMS about this Gestalt, and now I think that people are confused. So it seems that it's neither form nor.
I think I said half of those in essay, but I stretched a little bit.
Mhm.
So it's not, it's along the line of my essay, but I added something more. And
Yeah. Okay, any comments and any subjects? So how do you think? Yeah.
you're asking me or?
No, I'm asking you. So what do you think? Why do we? Is there any good
No,
reason to do science?
Can we go back to this last quotation, if it's easy?
Not that easy.
Okay, well, I should read it something. Well, last line say, every observation, as Karl Popper has stressed, is a result of a question we ask nature, and every question implies hypothesis.
Yeah.
So, no, this just important here, like what is objectivity and subjectivity? And well, to understand these two words, we have to understand what subject is and object is. So we are subject to observe, examine object out there. So there are always two things, subject, object. We can't take out either. Then there's no subjectivity, objectivity. Now, if you look at something out there, as it is, that's a question of objectivity. Although it's me as a subject, observe it, but question of objectivity is put myself away as much as possible to be objective. Another way around is looking at something like apple, and I feel this looks delicious and I want to eat. That is subjectivity, because actually I'm talking about myself rather than apple itself. So that is subjectivity. And just if you once understood the notion of objectivity and subjectivity in this manner, there is no absolute subjectivity, no absolute objectivity. We can talk about these two notions only in dynamical sense. We put our subjectivity away as much as possible to be objective, but actually we do this because we want to know something. That is our subjective position. So we ask question because this particular question is important to us. But to get answer, we must be objective. So there's a dynamics always behind. And so there's no pure objective. So to know, well, we want to know whether it's snow again tomorrow, say, fine. And we develop something objective using bunch of mathematical method and computation technology and so on. All these are objective, but the reason we have all those is we want to know whether it snows tomorrow or not. That is our subjective interest. And we can't, that's dynamics of science and human, well, activity as a whole.
Okay.
And then I think that's where we are getting to, starting by the Gestalt and keep idea of this ontology, epistemology, and taxonomy. So math is great, but this has a meaning in particular cultural background. And what we call math is actually 21st century math. It's not exactly ancient Greek people did math. Not only we know better something, again, we should give up this linear progressive idea that everything improves over time. A matter of fact is we get something by throwing away something else. And so,
Okay.
anyway, I hope this is clear enough.
I hope so. Okay. Any more questions and comments? If not, so thank you very much.
Yeah, dziękuję bardzo.
And yeah, we see on the semi